Even in India, I think there are a bunch of companies that have started offering especially garbage bags or products made out of bioplastic. I think it's a great initiative. I'm not so sure what goes behind it, as in, how less polluting is it to the environment? Do you still need to take it to the landfill? So I'm still very unclear on the bioplastics, to be very honest. I do use it, but I'm not sure what the technology is behind it.
I'm making a plastic podcast, and this episode is on bioplastics. And I wanted to find out what people think about bioplastics.
I think bioplastic is a good way to decrease the pollution in our world today. But I don't know if the price is affordable.
Unfortunately, in this world we live in, you can't get away from plastic. And so anything that makes it biodegradable is a much better solution.
Bio-based and biodegradable? I don't think I know too much of the difference between those.
I don't know, I guess I'm still skeptical about biodegradable plastic. Anything that's plastic to me, I'm still thinking this is still nearly impossible. And people also have to do the right things with it. That, to me, I think is the biggest limitation. But, if I have a choice between biodegradable plastic and normal plastic, I'll, still take their word for it and try it out.
You're listening to Plastisphere, the podcast on plastic, people, and the planet. I'm your host, Anja Krieger. In this episode, I want to take a closer look at these new materials that seem to be popping up all over the market. Plastics that are advertised as compostable, biodegradable, or made from plants. When I first heard about bioplastics, I thought that this is the solution to our plastic problems. But then I found out that it's much more complicated. In 2012, I followed a bioplastic bag to the factory and talked to producers and scientists here in Germany. Back then, all the experts told me that bioplastics are no solution for marine pollution. But that was 7 years ago, and technology is always advancing. Plastic in the ocean is now recognized as a major issue around the world, and consumers are asking for alternatives. So I think it's time for an update. Can bioplastics solve our issues with trash? And what does bio even mean?
There are a lot of bioplastics or materials that are called bioplastics that are not biodegradable. They are bio-based, they are made from plants, but they are not biodegradable. And this is because biodegradable depends on the chemical structure of the molecule and not by the source it is made of.
A couple of weeks ago, I met with Constance Ißbrücker. She's a chemist and head of environmental affairs at European Bioplastics. That's the industry association here on the continent. At this point, they represent a tiny niche market. Bioplastics contribute less than 1% to overall plastics production. But the market is growing.
And it's really dominated by so-called drop-in materials, like, for example, bio-based polyethylene or bio-based PET. And these materials are just more or less equivalent to their fossil-based counterparts. So you can use them in the same applications. You can make bio-based PET bottles, for example, or you can produce a bio-based PE packaging.
These plastics are really convenient for the industry. Producers and recyclers can just drop them into their existing infrastructure without having to buy new machines. That's why they are called drop-in materials. They are made on the basis of plants, like sugarcane or corn, but are chemically identical with conventional plastics made from oil or gas. More than half of all bioplastics on the market are just bio-based, not biodegradable. And that means that they cause the same kind of pollution as normal plastics. So what's the point in producing them if they are not designed to break down in the environment?
I mean, the biggest benefit is, of course, very simply said, it's made from renewable resources. That means we get independent from oil or other fossil resources. And this has a very good impact on the whole carbon footprint. You save carbon dioxide because a plant takes up carbon dioxide from the atmosphere. And this carbon dioxide is then stored in your bio-based product. And the product maybe can be recycled. When it cannot be recycled any longer, it will be most probably incinerated, and then the carbon dioxide is set free. But all in all, this is a quite positive or neutral carbon dioxide balance.
I wondered if people know about the drop-in bioplastics that do not biodegrade. So I went out to the streets of Berlin.
Did you know that there are bioplastics that are bio-based, made from natural materials, but they're not biodegradable? Did you know that?
No.
Didn't know that.
And they're chemically identical to conventional plastics, like they're the same, they're PET or PP or PE. Do you know that?
No, I didn't know that. Why are they entitled to be named bioplastics then?
They are made from a renewable source, and so they save fossil fuels.
I see. Well, but still, I think probably we then have to define better how to certify bioplastics, because one important thing, of course, how you produce it is important, but also even more important is how it does disintegrate. And if it is not disintegrating, it shouldn't be called bioplastic.
I imagine bio-based is a lot more natural and would degrade, not instantaneously, but within a couple of months.
Isn't it? I mean, one is how it's made and one's how it's thrown away. So if something's bio-based, that doesn't necessarily mean that it's going to be able to go away. And same for the other way around, right? Can't you make things that would go away easy but aren't made from renewable stuff? Yeah, I don't know.
That's true. There are plastics derived from fossil sources that are in fact biodegradable. Just as there are plastics made from plants that do not biodegrade. Welcome to the complicated world of bioplastics. And growing plants to make plastic might cause other issues. Critics say this puts pressure on land needed to grow food. Bioplastic farms could threaten biodiversity and lead to an increase in monoculture cropping, pesticide and water use. The industry is trying to tackle this by switching to algae and waste materials as a feedstock. But they still have a long way to go. So plastics made from plants do not necessarily have a better footprint. And over 60% of them do not biodegrade, which means they will cause the same pollution as normal plastics. But what about the biodegradable ones? Can they help us tackle the problem? To find out more about biopolymers, I called up a chemist.
I believe biodegradable plastics are a great idea. However, it's difficult to make, let's say, a good biodegradable polymer, and I believe there's no one-fits-all solution.
Frederik Wurm is a scientist at the Max Planck Institute for Polymer Research in the German city of Mainz. He and his colleagues work on designing molecules for materials, which include biodegradable plastics. The lab is developing substitutes for polyethylene, as well as polymers for medical applications and mulch films for agriculture.
We need different properties of plastics in different applications. Sometimes it's lifetime, sometimes it's where they are used, if it's a humid area or if it's a very dry area. If you would like to pack a liquid, you probably need a different property than if you would pack something which is very dry, like flour or so.
When it comes to biodegradable plastics, the challenge for chemists like Frederik Wurm is to try to develop a material that lives not one, but two lives. The first one with all the necessary and desired functions for that product. And the second as food for microorganisms. Because that's what biodegradation means.
And depending on the kind and the amount of microorganisms, this can take long or can be a fast process. So thinking about seawater, where we have a lot of plastic waste currently, seawater is typically not so warm, so most of the sea is cold. And there are also not so many microorganisms around. That's why many of the classical, what people call biodegradable, they do not degrade in seawaters, or they take ages to degrade.
The sun, waves, or marine animals can break up plastics into smaller pieces. But that's not enough for the material to really enter back into the natural cycle. That's just simple degradation, and it will lead to yet more microplastics. For true biodegradation, we need organisms that can attack and completely break down the long molecule chains of the plastic.
So making the long chains into shorter chains or into fragments of these chains. And in the end, in the ideal case, they can also use that to build it up into their own organism and grow. Basically food for them. This is the process that we call bioassimilation and in the end mineralization, where the material is really used in processes of the organism.
Microbes produce enzymes, and some of them can act like knives and cut biodegradable plastic. But not every microorganism has the right knife for every type of polymer. So we need the right microbe with the right enzyme for the right plastic. If the microbe can break the plastic into small enough chunks, it can ingest them. And then, not unlike what happens when we eat, the microbe can use the food to gain energy and weight. In the process, it produces water, CO2, or methane. Frederik Wurm carries out a series of tests in the lab to see if a plastic biodegrades. He starts by exposing it to harsh acids or bases. If that doesn't work, it's clearly not biodegradable. If it does, he sees if enzymes can do the job.
And the final test is typically field testing, that I, for example, bury this in the soil or put this in seawater or put this in a compost or in activated sludge from a sewage plant, and I see if these organisms can degrade the material.
What would you expect? What kind of qualities should this plastic have?
It should be able to disintegrate very quickly meaning within a year.
Well, it should happen immediately, but it all depends on the application.
When I hear biodegradable plastic, I expect it's still going to take, a couple of years to degrade. I think normal plastic is 500 years. So when somebody tells me biodegradable, I expect maybe 5-10 years. Still take a long time, but a lot better than what we have now.
Even biodegradable plastics can take years to completely break down in the environment, if they do at all. And there's not only one kind, but many different types, which all behave in different ways in different places.
You're perfectly justified in being confused.
I called up Linda Amaral-Zettler, a microbiologist at the Royal Netherlands Institute for Sea Research. She and her team discovered the Plastisphere, the new ecosystems growing on microplastics in the ocean, which also gave name to this podcast. She's also very much involved in the discussion on biodegradable plastics. Linda explained to me how crucial it is to consider the time it takes for a plastic to completely break down.
Because everything's biodegradable over thousands of years. At some point, everything's biodegradable, right? But really, we want things that are going to be biodegradable and compostable in a reasonable time frame. And I think that, that is an important caveat, is when people think about how long things take to degrade and biodegrade in the environment, there needs to be a concept of time attached to the sort of definition.
Linda is part of a committee that deals with environmentally degradable plastics at ASTM International, the former American Society for Testing and Materials. ASTM is one of the organizations which develop voluntary standards for the industry. To get one of their labels, producers have to show that their plastic fulfills the criteria to biodegrade in a certain setting. Like, for example, in industrial composting, with hot and humid compost heaps. But when it comes to the open environment, especially the ocean, creating a standard gets truly tricky.
One of the biggest challenges and discussions that this community is having is whether the standards need to be reflective, completely reflective of the marine environment, or whether it's acceptable to sort of have a standard that tells us something about sort of the optimal scenario, where under warmer temperatures and sunlight and conditions where there's the most sort of favorable conditions for biodegradation, so the complete breakdown of plastic into molecules, simple molecules that organisms can directly use completely, whether it makes sense to just do those under conditions where you can see the complete end product being total use and incorporation or CO2 respiration.
For the marine environment, there is no standard for biodegradable plastics yet to clearly pass or fail. And the question is whether there ever can be one. Because the conditions in different parts of the oceans are not the same. They can be warmer or colder, lighter or darker, and more or less salty. And each ecosystem is inhabited by different organisms, including the microbes which might or might not be able to break down the plastics. At Hydra, a private research institute with a station on the Italian island of Elba, marine biologist Christian Lott and his team test biodegradable plastics. They immerse them in different ocean environments, for example in the Mediterranean or the Arctic.
Or we do it in the mangroves in the tropics where you have mosquitoes, you have to dig holes in the sand or in the mud with spiders and snakes around you. So it's challenging sometimes, but this is the work we love.
It's an adventurous task and one that needs a lot of expertise. Christian and his partner have developed a special testing frame so that their plastic samples don't get swept away with the currents underwater. Their field tests can run for years, and this way they can safely retrieve and analyze their samples. Most of the plastics tested at Hydra have already been shown to biodegrade under marine conditions in the lab.
But the critique is that these laboratory tests that are also found in American and European and ISO standards are optimized and do not necessarily reflect the conditions in the wild, in the nature, in the rivers, in soil, or in the ocean. And then we as marine biologists come into play and do these tests in an open system under the water, at the beach, in the mangroves, in a coral reef, in the sand, and observe how these materials degrade, knowing that in lab condition they would be eaten by bacteria.
There's one type of biodegradable plastic that seems to be almost impossible to digest for marine microbes: PLA, or polylactic acid. It's a quite popular material.
The structure of PLA, the chemical structure, is so, let's say, dense that it's really hard to be attacked by bacteria or fungi. This only works at higher temperatures or with strong acids. So these are the conditions you find in industrial compost with pure PLA. But you can modify, and this is the art of bioplastics manufacturing, you can blend, for instance, PLA with other substances to make them more prone to hydrolysis, which is the initial chemical process, and then to the degradation of the polymer itself by bacteria, for instance, or fungi.
Pure PLA is not readily biodegradable in the ocean. But Christian and the Hydra team found that all the plastics that did biodegrade in the lab also did so in their field tests.
But you have to keep in mind that also natural materials in the wrong, let's say, situation conserve forever. We have fish fossils that after 300 million years still show color from polymers, natural polymers.
So we can never say for sure if any material biodegrades in the environment. It really depends on where a piece of plastic ends up on its journey through the oceans, which is pretty impossible to predict.
Some of the very well-degradable materials, which, by the way, are produced by bacteria, which are called polyhydroxyalkanoates, they degrade in a tropical environment on the seafloor in a thin foil within 1 to 2 months. But in the Mediterranean, it can take 10 times as much. And imagine in the Arctic, in the ice, or at ice-cold water, or in the deep sea where we have 0 degrees to 4 degrees, hardly any nutrients around. Bacteria will take or will have a hard time to digest these materials.
Certainly they degrade faster than traditional plastics in the marine environments, but still they take time to degrade. And in the meantime, if a turtle or a dolphin meets a biodegradable bag, they could mistakenly consider them as food or something like that. And so this might be a problem.
Biodegradable plastics are no solution to marine pollution, says Enzo Favoino. He's a waste management expert at the Scuola Agraria del Parco di Monza. In his country, Italy, all plastic bags have to be compostable. And the industrial composters in the country accept and process these biodegradable bags together with the food waste. In some other places, like my home country of Germany, that's not the case.
We have long been using compostable plastics as a tool connected to separate collection programs for organics. In Italy, there is a long tradition of using such compostable plastics in order to maximize the captures of organic waste, which in turn minimizes the percentage of organics inside residual waste, and therefore it helps us optimize the separate collection systems as a whole.
Enzo serves as the chair of the Scientific Committee of Zero Waste Europe. He says that it is crucial to collect as much organic waste as possible to reduce the trash that goes to incinerators and landfills. The compostable plastic bags can help with that, Enzo says. They make it more convenient for people to collect their food scraps or garden waste separately. And that means that these organic materials don't end up in the residual trash. With less organics decaying in these bins, waste management operators can come by less often to pick them up. And that in turn motivates people to collect paper, glass, plastic, and metal separately, materials that can then be easily recycled. Another advantage is that less organic waste ends up on landfills and dumps. There, it can produce methane, a powerful greenhouse gas.
It's 21 times more powerful than carbon dioxide. And so this is the largest contribution to climate change from the waste management sector.
So the separate collection of kitchen and garden waste has two benefits for the environment: more recycling and less greenhouse gases. To this end, Enzo supports the use of compostable plastic bags. It's a closed system. The bags are sent to industrial facilities where they can biodegrade under controlled conditions. And that is very different from composting at home in a garden, which is why Enzo does not support a standard for home compostable plastics.
First of all, compostability in home composting systems makes no sense whatsoever, to my opinion, because people doing home composting would not need the compostable bags. Of course, because they just take the food scraps and they put them in the composting heap or in the composting bin in their backyard. But also, it gets the wrong message across because people would be mistakenly led to think that if it composts in the backyard, it would compost also in the countryside, which is utterly wrong, of course.
We speak of plastic as this monolithic giant, right? We speak of plastic as if it's one thing, but it's not. It's thousands of things.
Just as there are many different conventional plastics, there are different biodegradable ones. Different polymers can be mixed together in the products we buy, and what's often added is a whole array of chemicals. These substances can make the plastic soft or durable, transparent or colorful, or they protect it from sunlight or fire. It is the toxic potential of some of these additives and other substances from production that many people worry about. A woman from Vietnam I met on the street told me she expected bioplastics to be different.
I expect it will be better for the environment and also contain less toxic ingredients, I believe. In their process, making process wouldn't be that bad for the environment, and also they must be strictly supervised.
This would be nice, but new research suggests otherwise.
What I can tell from my research is that bioplastics are not necessarily safer than conventional plastics with regard to the toxicity of the chemical mixtures they include.
This is Lisa Zimmermann, a PhD student at the Department of Aquatic Ecotoxicology at Goethe University in Frankfurt, Germany.
So there might be products which might be better, there might be others which might not necessarily be better with concerns to the toxicity of the chemicals they include. But we can't say, okay, overall, the chemical toxicity of bioplastics is less than of conventional plastics.
Lisa was at a conference in Helsinki when we Skyped. She had just presented first results from her experiments with chemical mixtures she extracted from bio-based and biodegradable plastics. One organism she worked with was a bioluminescent bacterium, which can glow.
And if something interferes with the metabolic activity of this bacteria, the luminescence decreases. And the more the luminescence decreases, the higher something seems to interfere with the metabolism of this organism. So that's a measurement for what we call baseline toxicity. And what I saw, for example, in this assay, that more than, or it was around 2/3 of all the plastics products, bioplastic products I tested, they inhibited these bioluminescence. So they somehow seem to interfere with the metabolism of this organism.
I often go to a farmer's market here in my neighborhood in Berlin. Not long ago, one of the organic farmers there offered me a bag that looked like plastic. I said, no, I don't take plastic bags anymore. But he said, no, this isn't plastic. Which made me really curious, so I accepted it. It was a white bag with a big green tree printed on the side, and there was a description in Polish on it. For the sake of the environment, an oxo-degradable bag, it translated. Later, I learned that these are conventional plastics like polyethylene, but they are mixed with metal compounds that make them fall apart faster. A report by the United Nations Environment Programme says that it hasn't been proven that oxoplastics truly biodegrade. It is feared they might just accelerate microplastic pollution. I told Linda the story of the bag I got from the organic farmer.
It clearly is not his fault, right? I mean, how can, the green grocer or the organic farmer stay on top of all this controversy, right? I mean, I can barely stay on top of all this controversy. And I'm dedicating a large part of my career to this problem. But there you have it, right? You have this scenario where people really want to embrace and do the right thing. And yet, we're being misled. How to confront that?
The European Union has now decided to ban oxo-degradable plastics. And there's another kind, the so-called enzyme-mediated plastics, which haven't been proven to truly biodegrade, according to European Bioplastics. Their industry expert also told me that there have been misuses of the accepted standards and labels. No wonder it's so hard for us consumers to understand whether the claims we find on a product are legitimate or not. Three years ago, Imogen Napper, a PhD student at the University of Plymouth in the UK, collected bags in the stores that were touted as degradable or even planet safe. She submerged some of them in the sea, buried others in the soil, and left some sitting out in the air. After 3 years, to her surprise, she found some of them still intact.
Not one of the bags could completely vanish or completely degrade in all of the environments. And particularly in the soil and the marine environment, some of the bags could still hold a full bag of shopping.
During my research for this podcast, I came to believe that bioplastics might just be the most confusing material humans have ever invented. Even some of the experts told me they struggle. So let me try to wrap this up. Bioplastics occupy a tiny market. Only 2 million tons are produced each year, compared with hundreds of millions of tons of conventional plastics. And half of the bioplastics are just bio-based, not biodegradable. Whether the other half can really biodegrade depends on the type and mixture of plastic, the environment it ends up in, and the microbes that are present there. Because they are the ones who do all the work. There are no globally accepted standards yet to make sure bioplastics can degrade in soil or the oceans, and some say it's better that way. Because in the open environment, the materials we have today are no solution to plastic pollution. Could this change with new technology? I asked Frederik Wurm, the chemist.
So there are at least academic approaches for that. So being a chemist, a synthetic chemist, you can build in many molecular triggers. For example, when you have a certain wavelength of light or maybe electricity, magnetism, there are many stimuli that you can install into a synthetic polymer chain. When you switch this stimulus on, it will degrade. But this is It sounds fancy, it is fancy, and it's expensive.
Unfortunately, it's not only an issue of cost. Building molecular triggers into every material for every environment seems to be an almost impossible task. And plastic is a traveler, so we can never know where it might end up.
I do not think it makes sense to make marine biodegradable packaging. And even if you do so, you should not label it as a marine biodegradable packaging, because for consumers that would mean, I can just throw it away. It would give the wrong message.
And that leaves us with the good old low-tech solutions to plastic pollution.
By just reducing the amounts of packaging that we have and the types of different packaging that we have in our supermarkets, we can do a lot without developing novel materials. Just reducing it and see what is not necessary.
The bioplastics we have today might offer benefits for some applications, but they are not going to magically disappear when we are done with them. The most environmentally friendly plastic of all is still the one that we don't use. This was the Plastisphere with Constance Ißbrücker, Frederik Wurm, Linda Amaral-Zettler, Enzo Favoino and Lisa Zimmermann. Many thanks to all experts for sharing their insights. I also thank the people who participated in my bioplastic poll on the streets of Berlin. This episode was inspired and partly supported by ENSIA, the solutions-focused nonprofit media outlet reporting on our changing planet. Learn more at ensia.com. My name is Anja Krieger, and the music was composed by Dorian Roy and Blue Dot Sessions. Huge thanks to these wonderful musicians. For more tracks, visit sessions.blue. I also thank Maren von Stockhausen for the cover art, Ines Blaesius, Stephanie Hood, and Luisa Beck for feedback, as well as Sirine and Rached for putting me in touch with Enzo, the awesome Twitter community for their thoughts and links, and the Max Planck Institute for the History of Science. The quote of Imogen Napper was provided by the University of Plymouth. And Markus Anhäuser edited the German article on Riff Reporter. This podcast is an independent production. I have no staff position anywhere, and I'm funding this project mostly myself. So, any contributions would help. Go to plastisphere.earth and click support to help fund future episodes. If you enjoyed this episode, please rate and review the podcast on iTunes and share it with your friends. Thanks for listening, and I hope you'll tune in again. Until then, bye-bye and tschüss. See you next time.